Hi everyone, this video we're going to do a bunch of examples to help you get good at graphing different sine and cosine functions. So this first example, you could find it in the packet. I believe it's the first one. Y equals 1/2 times the cosine of x. My graph goes from like negative 2.5 pi to 2.5 pi, where I think yours just goes from negative 2 pi to 2 pi. So they might look a little bit different. Just please be aware. All right. So looking at this, I have the things we learned in the last video up top here. So it's easy to see that the amplitude A is the number in front of the cosine, multiplying or dividing of 1/2. And then our frequency would be B. That's a number in front of the x after the cosine. There's nothing there, so I know there's a frequency of 1. And then that would help me figure out the period using the formula 2 pi divided by b, 2 pi divided by 1. We have a period of 2 pi. So this is actually going to look fairly similar to what we've done in the past so far, is that we know it's going to take 2 pi before we get one cycle in, and then the roof and the floor, it's going to be a little bit lower at 1/2. So I think what I'm going to do is instead of go up by ones, I'm going to go up by 1/2 just so I have a little more room to see what's going on here. Okay. I like to spend a little time kind of making parameters before I actually do the graphing. So the first thing I'm going to do is I have my midline at the x-axis. That will change tomorrow, so it's worth thinking about. Now let's put the roof on. With an amplitude of 1/2, the roof is going to be only up at 1/2. And then the amplitude also goes the same amount below the midline, negative 1/2. All right. And then with a period of 2 pi, we know that we start our graph on the y-axis, and we will go 2 pi before we get a full cycle through. So I'm going to highlight, it's kind of neat right in here, this little box I've created helps me know where my cosine graph is going to go. I am going to ask that you guys always try your very best to do 2 cycles through. So I'm going to go 2 pi to the left. So I'm going to have one cycle in this box here, one cosine, and another one in the purple. Okay, so now I'm ready to start plotting my points. If I think of a cosine, that parent graph, remember cosine is that U shape starting up and ending up, okay? So let's think about it. On the corners of our building, they're going to start up at 1 and end up at 1. So we're going to have the, that's going to be these two points on our cosine graph. And then in the middle, halfway through, we will be down at the basement. So at the ends, we're up at the ceiling. Halfway through, we are down at the basement. And then the other 2 points we need are the ones on that x-axis where you cut 0 to pi in half and cut pi to 2 pi in half. And that creates that U shape, so you can do a really nice curve. Let's do the same over here. We have the walls, we have the ceiling and our floor. We know the points on the walls will be up at the ceiling, so the upper left and the upper right. And then we know in the middle, the bottom of the U is going to be on the floor. So halfway between 0 and 2 pi is pi. So at pi, we're down on the floor. And then we need the 2 points, the averages between the end and the middle and the other end. Those are on the midline. So there is our second cycle of y equals 1/2 cosine of x. So the thing that's different about this than y equals cosine of x is y equals cosine of x would have started higher up at 1. So it would have been stretched out. This one was made a little bit shorter. All right, pause it if you need to. Let's go on to the second example. This one, we have y equals cosine of 4x. I believe it's number 2 if you have the packet printed out. So let's go through very quickly. Y equals a sine of bx and y equals a cosine of bx. I like having that right in front of me because then I just never really get confused at what I'm looking at. The amplitude is a number that's multiplying in front of the sine or cosine. There's nothing there, so I really know it's a 1. And then the frequency is the number in front of the x is a 4. And what that's telling me is that between 0 and 2 pi, I'm going to have 4 cosine cycles through. So this is going to be like an accordion scrunched in pretty tight. And to get that actual period, 2 pi divided by 4, that's telling me that every 1/2 pi, on my graph, it's written as 0.5 pi. On your graph, I don't even know if it's there at all. You might have to set it up. Okay, so that's saying every 1/2 pi, we have a full cosine cycle. So it's going to be pretty tight. So let's go ahead and kind of get everything set up. Where did I put my black marker? Oh, there it is. To get everything set up, instead of start drawing points, I like putting the walls and the ceiling and the floor on. So my midline is at the x-axis. And then with an amplitude of 1, I'm going to go up 1 and down 1. I'm going to change the scale. I've kind of, all of mine so far have been up by halves. So it looks like the ceiling is going to be up at 1 and the floor is going to be down at -1. And now let's put the walls on for 1 cycle. We're going to always start on that positive y-axis. And this time, between 0 and 2 pi, so far I've always only had 1 cycle there. This is saying a frequency of 4. I'm going to have to fit 4 cosine cycles in there. So it's saying that every 1/2 pi or pi over 2, I have to complete a cycle. So I see 1/2 pi. And then I go 1/2 pi again to pi. And then I go 1/2 pi again to 3 pi over 2 or 1.5 pi. And then 1/2 pi again to get to 2 pi. So this is a pretty skinny one. If you look right, nope, there's my ceiling. Right in there is where I'm going to have 1 full cycle. And then you can see I'll have my second full cycle right next to it. And then we'll have a third one and a fourth one. So you can see again why the reason the frequency is 4. Here's 1 cycle, 2, 3, 4. There's 4 cycles from 0 to 2 pi. So in this case, the period, like we said, is 1/2 pi. All right, let's go ahead and put these points in. When we do that, we know a cosine graph, if we think of what it looks like, it's that U shape. It starts up and it ends up, and halfway through it's at, so it starts and ends at the ceiling, and halfway through it's at the floor. So in this purple guy, starts and ends at the ceiling, and then halfway through, that's going to be at 1/4 pi, it's down at the floor. So now we need the 4th and 5th points. Those are going to be halfway between the start and the middle. So on the midline, it's going to go halfway between, and then between, it's going to go halfway again between the middle and the end on that midline. Do your best here to not have it look like a V, have it look like a curved U. And then I think you can follow the pattern. We could pretty easily get 4 cycles through here. So in the yellow, it's going to start and end at the ceiling, and in the middle, it's going to be at the floor. And then the 4th and 5th points to help guide will be halfway between. So there's a second cycle. Then a third one in this box here, start and end at the ceiling. In the middle, it will be at the floor. On the midline, halfway between each. Do the last one. Start and end at the ceiling. Halfway through on the floor, and between those you have the midlines. So you can see how this 4 right here really kind of crunched the cosines together. It's like if you think of it as accordion, that frequency being higher crunched it together. So pause this if you need help finishing this up. We're going to go to the next example. All right, this next one, y = 3 times the sine of x. I believe if you have the packet, I think it's number 4. You can look and find it. Y = 3 times the sine of x. And we remember our amplitude is a number that's out in front multiplying the sine. It's clear to see here I have an amplitude of 3. And then the frequency is B. That's a number between the sine and the x. There's nothing there, so it's really a 1. So that tells me this one, the accordion is stretched out to normal because remember the frequency is how many cycles in 2 pi? This will just be 1. So to find that period, you do 2 pi divided by b. So it's 2 pi divided by 1. So that tells me it's going to take 2 pi to get 1 full cycle in. That's nice. If you wanted to draw in the walls right now while you're thinking of it, go for it. It starts at the y-axis, and it's going to go out to 2 pi. All right? And then I would do a second cycle in the other direction from negative 2 pi to 0. Now let's back up and go ahead and put the midline on. The midline is on the x-axis. And with an amplitude of 3, the stretch of 3, this is going to get stretched real big. The ceiling and the basement are going to get pretty tall. So if I have, this time I think my scale will just have to be like normal, 1, 2, 3, and 4, so it fits on the page. So I'm going to put the 3 way up here, and then I have to go the same into the basement, 3 the other direction of the midline. So you can see this time it's a pretty big box. In the last problem, the box was really small. This time I have a really big box to fit 1 sine graph in. And then we will do a second cycle through over here. Always try to get 2 cycles through if you can. It's not always possible, but we will try. It's what you'll strive for. All right, so now we have to think of a sketch of a sine graph. We haven't done one of those yet. Remember, the sine graph looks like a roller coaster where you'll have 3 of the 5 important points are on the midline, and then when you go between, you'll only hit the ceiling and the floor once. Okay, so when we think about this, remember we always start on the y-axis, and on the sine graph, it starts on the midline and it ends on the midline. So the 2 walls are at the midline, and then halfway through at pi, we hit the midline again. So now when we go from the beginning to the middle, we go up first. You go up the roller coaster first. So halfway between them, you hit the ceiling. And then from the middle to the end, we go down and halfway through hit the floor. So that nice sine curve, you go up, down the big drop of the roller coaster, and end where you started. So let's do that again over here. The left wall, you start at the midline. The right wall, you start at the midline. And then halfway through, you're at the midline. So those are the 3 points on the midline. Now to go up between the beginning of the middle, we cut that in half, go up to the ceiling. And then to get the 5th point between the middle and the end, you cut it in half, go down to the floor. So there are 2 cycles of our graph, a sine graph with an amplitude of 3, a period of 2 pi, a frequency of 1, because we only see 1 cycle through in 2 pi. All right, I've got one more example for you. This is kind of throwing a lot at you. I hope you're still with me. This will be a great example to have. It's another sine, which I like because we've practiced a couple cosines. I always remember y equals a sine bx. So here the amplitude comes in front of the sine. The amplitude is 2, so our ceiling and floor are stretched a little more than normal, not as much as the last problem. The frequency says 1/4. Oh, that's interesting. This accordion is going to be way stretched out because this is saying in 2 pi, so from here to here, how many cycles will we see? We only see 1/4 of 1, so this is going to be kind of crazy. So then the period, 2 pi divided by 1/4, flip the bottom and multiply, is actually going to be 8 pi. So when I look here, I go from negative 2 pi to positive 2 pi. I won't even see 1 full cycle because this is only 4 pi long. It's going to take 8 pi to get there. So how I've been saying, we try to get 2 cycles through showing on a graph. This one won't even show 1, and that's okay. I'm not going to change the scale because I really want to illustrate that this guy is stretched out. Okay, start with what we always do, midline first. Midline first for now is always the x-axis. All right, Step 2, we're going to do the amplitude, ceiling and floor. So with an amplitude of 2, ceiling and floor. All right, and here's where it's going to get a little tricky. With a frequency of 1/4, I'm going to start here. And you know what? For the sake of kind of being the same as what your guys' graph has, your graph doesn't have this part. Your graph ends right there, and your graph starts right here. So let's pretend that what I'm crossing out isn't on my page. This looks more like what you have from -2 pi to +2 pi. So let's think about it. Gosh, all right. How do I want to go about this? If I think of a sine graph as that roller coaster, let's break this picture up a little bit. I'm actually going to draw it a little bit bigger here if we do a sketch. What this is saying is that this is 0. This is 8 pi because the period, it's 8 pi to do a full cycle. So that means halfway is 2 pi long. Nope, not 2 pi, not even that. It's 4 pi. So from here to here, from 0 to 2 pi, well, 2 pi is halfway. So all I'm going to see from here to here is that first point and then this guy up at the top, because that is 2 pi worth, and that's what I can see. It's not much. So if it would help, here's the box. And it's going to keep going, even though past what we can see. We're just going to graph what we have room for. The sine, it starts on the midline. And then when we're 2 pi into it, it's going to be up at the ceiling. So all I can see is that. All right, you can imagine that it's going to keep going, but we can't see it. Now over here, what's going to happen is we're going to see the last fourth of the previous one. Some kids say, well, why don't you just start it over here so we can see more of it at one time? It doesn't work that way. You have to remember that the start of a sine graph is on the y-axis right here. So we're going to see the beginning of one and the end of the other. So when I look over here, when I think about seeing the end of the other, I have 2 pi here on my graph. So that means I'm going to see from like the back part of it, if you would think of it as 6 pi to 8 pi, all I'm going to see is the bottom and it ending at the midline. So if you think about it, this is a part of a different guy that's going to go on forever. It's going to end here, and then 2 pi over, that's when it's at the bottom. It's in the basement. So all I can see, believe it or not, is that. It's hardly anything. This accordion is way, way, way stretched out. Okay? I have one more video. I encourage you to come and watch it. It will help. Stick with me. You can do it.